This is a short video on the Field Controls Flue Damper model GSW24. It was mounted on a residential gas-powered water heater model B4386 made by A.O. Smith/GSW in Canada. The water heater failed with end switch failed open, indicated by a 3-second pause on the controller LED. The Flue damper assembly can be purchased for between $225 and $275 Canadian price. First I'll show you a roundabout view of the Flue damper assembly. You can see the flap valve. That's vertical. When the burner's firing, turns another quarter rotation to be closed over the heating pipe as an efficiency measure when the burner is not firing. Parts we're going to have a look at are in the box where my left hand is. We'll need to get in there, and to do so we're going to drill the flanges off the pop rivets, 4 of them, using about a 1/4 inch diameter drill. Not really fussy, just as long as you can get the flanges to let go. Again, we want to take care that we don't knock the damper out of round so that the flap valve doesn't want to turn. And we remove that cover. First thing we can see is the gear motor that turns the cam, which operates the switches and also turns that flap valve. Again, it turns 1/4 rotation each movement, and it's counterclockwise when you view it from the damper valve side. 2 Phillips screws hold the motor in place. This is what we want to do, is access that control circuit board, the green thing with the shiny silver dots. That grid of 3x3 dots represents the connections for the 3 micro switches, one of which appears to have a fault. The cam, which has 3 lobes on it, serves as a coupling between the gear motor and the flap valve itself. That Y-shaped piece separates the circuit board and also has a pair of pins on it that help hold the circuit board in place. Those 2 pins go through the mounting holes of the micro switch, and there you can see them. There's a mating pair that come up from the chassis on the other side of the micro switch row. Take that off, get it out of the way. There you can see more clearly the cam, the micro switches between the circuit board and the cam itself. And pull that circuit board off the pins that are on the chassis, and you can see the row of 3 micro switches. My thumb is on a relay. I didn't investigate what everything else does. I'm testing the switches. 1 out of the 3 of them did not sound like the other 2, so it's my immediate suspicion that that one might be faulty. Again, you can see other components on the board. I didn't draw out the schematic. I don't know what they do. I'm setting my voltmeter so that it beeps on good contact, and I'm choosing the 200 ohm range. A good switch will test 0.1 to 0.2 ohms when it's closed. There you can see the switch contacts, common separated from the normally open and normally closed. Normally open will be high resistance until triggered, and then 0.1 to 0.2. Normally closed is opposite. It should read 0.1 to 2 until the plunger our actuator is pushed, and then it's going to go high resistance or infinity ohms on your digital voltmeter. It can be tricky to hold these on the circuit board, but you can see when activated it'll read 0.1 to 0.2, and when it's not activated it'll be infinity, i.e. greater than 200 ohms. So that's a good switch. And here's a bad switch, nowhere near 1 ohm or less. So that's the one we're going to concentrate on. That's also the one that sounded funny. We're going to squirt in some contact cleaner. This one has a lubricant. You can use any contact cleaner, or in a pinch spill in some isopropyl alcohol. I'm going to squirt it by the plunger, the actuator, and there's a little slot of a hole at the other end of the switch. You can squirt some in there as long as you get some inside. Then you're going to do 10 or 15 presses on the plunger to get that contact cleaner working. I don't want to take it apart twice, so you see I do a second dose followed again by a few actuations of the plunger. And then I'm going to retest and see what it does. The switches are made by Zippy, and as far as I can tell, the closest part number would be an SM-05S03A2Z, and an equivalent would do just fine. It's kind of a regular force, regular micro switch, capable of 1 amp at 250 volts. On the retest, you can see that closed resistance lower than 1 ohm. It's 0 to 0.1. Flip that board over. Going to push it back onto the pins. Those pins you can see there will go into the micro switch mounting hole and keep it registered so it can't move away from the cam. When I put the Y-shaped piece on the top, it sits on those 3 standoffs and will prevent the board moving up and down. You can see me checking that the cam rotates, and you can see the flap valve moving at the same time. There's the Y-shaped piece, there's the 2 pins. They're going to go into the mounting holes on that row of micro switches. Make sure they're properly registered on the standoffs, and then you can put the motor back on the top. 2 flats in the shaft. Doesn't really matter how you register it into the cam, because the circuitry is going to turn it until the flap is properly positioned for either gas firing or gas not firing. Give it a wiggle, on it goes. Then we're going to put the Phillips screws back in, and again we're going to check the cam and the shaft and the flap valve to make sure that binding isn't happening. Checking the cam. And again, having a look at the flap. You may have to drill out the remnants of the rivets, as you can see I'm doing here. And if they persist, then get a pair of pliers, vice grips, and pull out those little bits. So otherwise you won't be able to put the new pop rivets in. So there's my 4 little bits. I know where they are, so I know they're not in some other electronic or electrical stuff that is lying around my messy work area. See the 3 mounting tabs where it fastens to the top of the water heater. So I'm going to slide that on, make sure the tab is outside the cover itself. Pop rivets, I believe they're 1/8 diameter, maybe 3/16 grip or range, whatever you want to call it. There's only two thin layers of maybe 28 gauge steel to hold together, so the grip range doesn't have to be great. I'm going to start both rivets so that when we crimp one, the other one is in position. It'll save some time, as I found out later. And we're going to crimp until we hear the snap. And we collect the shanks as we go. You can see both the front rivets are in, and now we're going to do the top ones. Of course, we have to make sure that the end of the cover is underneath the bell shape that is on the top of the flue damper. Getting the first one in is easy. I guess I could have done a partial crimp to save the difficulty you see here as I try and get the rivet started through both holes. Could have drilled that out too. So eventually I get it in. And again, pull that rivet up until it snaps. So there's my 4 shank pieces, so I know they're not in anywhere else. Away goes the pop rivet stuff. I'm going to pick that unit up, give it a shake, make sure there's nothing loose inside. Grab a pen, note down what I did and when. This is a temporary repair. I'm always interested in how long temporary repairs will last. In the meantime, I'll have happy tenants with hot water. And until I settle the warranty issue, I'll have a working unit. Just pointed out the 3 mounting tabs. Here I'm checking to make sure the shaft for the flap valve isn't binding on anything. And again, move it just to make sure it moves freely. I eventually did get the warranty. I'm still waiting for the 2 weeks until it arrives, and then I'll keep it as a spare. One more time, the 360. Flap valve, 3 mounting tabs. They're 1/4 inch self-tapping machine screws that hold it on the top of the water heater. 24 volt AC input from the wall wart. That connector goes down to the burner assembly and the control that's on the front of the water heater. This is what it looks like when it's in place, and of course you'll put the venting assembly back on the top of the flue damper when you're done, and plug in the 2 connectors. Thanks for watching, hope it was useful, and again, it's a temporary repair. It's at your own risk. The part number for a new one is there. The part number for a micro switch is there. And proceed at your own risk. Thanks for watching.